Welcome to Powerplant for the Airbus A350. This is broken up into 8 sessions, and session 1 we're going to get the overview and introduction to the power plants. Session 1 is overview and introduction. Session 2 is engine general. That will also include the compressor control as well as the turbine section. And session 3 we're going to be going over the thrust reverser system. Session 4, propulsion control system. Session 5, fuel system. Session 6, engine air system. Session 7, engine oil. And the last session, session 8, is engine starting and ignition. Power plant. All right, this is a little bit different with the A350 as far as the engines that are installed on it, because you have A320s that are installed with various engines from different manufacturers. The A350 specifically is installed only with the RollsRoyce Trent XWB. The XWB variant or model of Trent was specifically engineered for the A350. So you won't find it in any other aircraft, or shouldn't. It's supposed to be specifically for the A350. All right, so with this, I'm going to go into a little bit of history on the Rolls-Royce and its development of the Trent series, because there are a variety of models that are Trent or variants, and then we have also kind of sub-variants to those variants. All right, so just to give you an idea of, in case you come across other aircraft and you see the Trents in the power plant, you have the XWB that got developed from the Trent 700. There's also the Trent 800, 900, and 1000. There's also a 7000. I'll get into a little bit and how that relates to aircraft. But the Trent series, and in particular the XWB, it was developed from the Trent 1000. Okay, now the differences with the Dash 800, Dash 900, Dash 1000, or Dash 7000 is in the design. There's some design differences, but we're also talking about ratings, and I'm talking about takeoff thrusts, which you can also have within each of those variants. Like the Dash 900, you could have one that might be a little bit varied depending on the takeoff thrust requirements for that particular aircraft. For the A350, it's the XWB, and the XWB can have subvariants of Dash 775. So, for example, Trent XWB Dash 75, or you may see one that says Trent XWB Dash 79, or 79B, or Dash 84, Dash 97. Those are the indications for the foot-pounds, and we're talking about in thousands, because when I say Dash 84, we really mean 84,000. Okay, so that means that XWB variant is the right power plant for a particular aircraft with a foot-pounds requirement of 84,000 foot-pounds. So that's what that is, 84 foot-pounds of takeoff thrust. On the history of the Trent with Rolls-Royce, Rolls-Royce is a British company, manufacturer of aircraft engines since World War II. But there's so much history with Rolls-Royce, you can look up more on your own. But they are known for building aircraft engines. And the developments have been varied since World War II, obviously, with new technology. And what we have here when we're talking about the Trent is your standard high bypass turbofan aircraft engines, and of course the ratings are based on those takeoff thrusts. The material themselves, back then, it was different material. Here today we have titanium hollow fan blades. Also, there's a little difference with the design of it, in that we have what are called blisks. So we have a mixture or a combination of blades with discs, so they're one piece instead of having two pieces. And just the way they're structured, they're just more fortified than some earlier models. All right, and on this particular one, as far as from, we're talking about the XWB, there are 68 high pressure turbine blades. Now, how many engines does the A350 have? It has 2. Okay, A320 has 2, and the A350 also has 2 engines, one under each wing. And there may be different takeoff thrust requirements with that A350, but they are still installed with that Trent XWB. So it just depends on the fan diameter. You've got the ranges with the 350 as far as the installation of a particular variant of the Trent XWB, and that would be from 75 to 97,000 foot-pounds. The first Trent, just a little history, was the 700 model that ran in 1990. By the way, the word Trent is named after the River Trent that's in the Midlands of England, and that's a kind of a typical thing that these manufacturers in Great Britain would do, is name some of their components after rivers. The second biggest supplier, this is what Rolls-Royce, as far as their aircraft engines, they are second place behind General Electric, General Electric being the first, and then Pratt & Whitney follows the Rolls-Royce. Just to give you a lay of the land, so to speak, with the aircraft that are using or installed with the different Trent models, you have on the Boeing side, the 787 Dreamliner is installed with the Trent 1000, and there may be some others, but that actually was designed for the Boeing 787, so you'll see a Trent 1000 with that one. And then with the Airbuses, you have your Airbus A330 Neo. Okay, that's your new engine option version, and that particular one is installed with the Trent 7000. And then your Airbus A380 is installed with the Trent 900. All right, so just to give you an idea, of course, the 350 with the XWB, that's what that designation is, a variant. Okay, all right, let's start with a question 1. These are your review questions, so just follow along in your video notes and review questions. Question 1, the variants are designated by a number in it. What does that number indicate? You have 2 choices. Number 1, the year that the variant was created, or option B, the foot-pounds of takeoff thrust. That would be B, foot-pounds of takeoff thrust. Okay, now let's go a little bit on the incidents revolving the Trent XWB. Certainly we can talk about accidents that occur with aircraft, and in particular I'm talking about the aircraft A350, but how is it relating to the engine itself? There have been incidences having to do with ice that was released from the fuel system that then accumulated on the heat exchangers. So what that did is it restricted the fuel flow, because I'm talking about the fuel oil heat exchangers, and then it just didn't have enough fuel going into the engines, which of course causes a problem. So you had incidences related to that. All right, question number 2. There are 4 engines mounted on the A350 compared to the A320, which only has 2 engines. Is that a true or false statement? That's false. Remember, I said that it has 2 engines mounted under each wing. All right, so that concludes session 1. That was just an overview and giving you an introduction to the particular engine that's installed in the Airbus A350. It is the Trent XWB that was specifically designed for the A350. All right, we're going to move on now and get into detail on engine general. Even though it's called engine general, there's actually a lot of information that we're going to be covering in session 2. Welcome to session 2, engine general, for the Airbus A350 Powerplant topic. That we're going to cover the nacelle, okay, and go into the cowls and the opening and closing of the cowls, all the latches so that you can access, opening or, opening the, changing the latches so you can actually deploy the cowl doors, etc. The nacelle is just simply an enclosure for the engine and all the related assemblies, and it is located under the wings of the aircraft. And the major assemblies, just to give you an idea on what we're talking about with major assemblies, you have the thrust reverser assembly as well as your exhaust system, of course your cowl doors. Okay, that's going to be your for your fan cowl doors, as well as the cowl doors for the thrust reverse. And then you have your air inlet cowl. Your air inlet cowl is just taken in, obviously air, when it first comes in to that whole power plant, and that is attached to the front of the compressor case. Then you have the fan cowl doors that are there as well. It's going to provide an aerodynamic surface between the air inlet cowl and the thrust reverser. There's also your thrust reverser assembly that has two halves. Those two halves are also referred to as C ducts. The K ducts, I mean D-U-C-T-S, and those are attached to the pylon and have translating sleeves that move, so be careful with all of that. You have an exhaust system that has three sections. You have forward and aft exhaust nozzles as well as an outer exhaust nozzle. All right, let's talk about the air inlet cowl a little bit. Be aware that the components associated with the air inlet cowl, one in particular is the anti-icing. There's a temperature probe that's located at the 1 o'clock position for that reason, and the purpose of the inlet cowl is just to direct the air coming in so that it can get compressed, etc. And back to the nacelle anti-ice system, this is just going to provide the engine bleed air to the D-section cavity to prevent ice from forming. All right. Now, fan cowls, you do have two fan cowl doors that are located between the air inlet cowl and the thrust reverser. And like most of these aircraft components, they are aerodynamically designed just to help, obviously, with the efficiency of the whole mechanism. The fan cowl doors, there's just kind of to get an idea on the construction of them. There are 4 frame stiffeners on the inner surface of each of the doors. That's just to give them that strength. There's 4 attachments. There's 3 aft that are fixed from the pylon, and then you have a forward hinge that's free floating, but it's also connected to the opposite fan cowl door. There's 4 latches that secure both the doors together, and those are located at the bottom, okay, to close around the compressor case. All right, and there's diagrams that can give you an orientation on what is what. I mean, there's an oil tank access door as well, for example, on the fan cowls. The hoist points I mentioned, there's 4 of them with the fan cowls. And there's hold open rods, of course, we'll have that. All right, let's talk about latches. There's a lot of latches, and you're not going to be memorizing any of this, by the way, but just to heighten your awareness about the latches and the mechanism for unlatching the latches and closing them as well. And there's some protective devices as part of that in case you forget to latch one completely down, for example, after you've accessed through the access panel. So right here on the fan cowl, there is a latch access panel that's going to give you access to the latches when you're wanting to open those fan cowls. With the fan cowls, there are 5 latches, and there's a procedure, and you want to make sure you follow the sequence properly, because if you don't, you're going to cause damage to the fan cowls, any of the cowls. If we're talking about the thrust reverser cowls, same problem, is that you could potentially cause damage. So do make sure you follow the maintenance manual as what it states for the sequence. But to open the fan cowls, you're going to release, you got to get access through the access panel. So in order to release the latch access panel catches, you're going to do that by pressing the opening buttons. And then the second thing is you're going to open the 4 latches that hold the fan cowls closed. Okay, so there's 4 latches for the fan cowls. And then you're going to be pressing an up button to activate the power door opening system. All right. And then when that's happening, just be careful, you know, let it do its thing, you know, automatically. When it's finally reached its max angle, you're going to have those hold open rod safety locks that are going to engage. And just watch for the band. There's an indicator on there that lets you know that those hold open rods are securely in place, okay, before you start, you know, doing anything. But there's a green band. It is visible there on the lock assembly. It'll let you know that they are locked securely. Okay, and just so you know, there are 2 positions in which those safety locks are engaged properly. That's at the 37° and 50° angles. Okay, now what about closing? That was to open. If you're going to close the fan cowls, you're going to activate the remote handle in order to delatch the locking collar that is located on the hold open rods. Okay, that'll be done. And then just for a short period of time, just press the up button on the PDOS. That's your power door opening system, and that's going to release the locking collar on those hold open rods, because you want to bring it, you know, that you want to disengage that so that you can close the cowls. And then you're going to press the down button so that those fan cowls start to go down. And then just when both of the cowls are lowered, you're going to close the latches, and then you're going to close the access panel by securing those 5 catches on the panel. And just, you know, make sure they're all flush. Just visually check to make sure that everything is, you know, looks good. So that's what you have with the opening and closing of the fan cowls. All right, it's time for a test question. Let me go ahead and put this in here for you. All right, just follow along in your video notes and review handout. This is question number 3. Name 2 major assemblies of the nacelle. Okay, choice number 1, thrust reverser assembly and exhaust system, or 2, ice protection system and inlet cowl. Okay, be careful. I know I mentioned the ice, you know, about de-icing system there, but it's not a major, considered a major assembly. Okay, the answer is the first one. Question number 4, what is the first step in opening the fan cowls? Okay, is it the first answer, press the opening button near the main landing gear and the latches will drop? Or B, release the latches of the latch access panel in order to access the 4 fan cowl latches? All right, it's B. Okay. And I know I mentioned this. I'm going to mention it again here when we're talking about thrust reverser cowls, but I did mention it, so I'm going to go ahead and do one more question here. This is question number 5 before we continue our lesson. There are 2 similar halves of the thrust reverser cowls. They are referred to as, is it C ducts or D ducts? Okay, the answer is C ducts. All right. Okay, let's go ahead and continue with our lesson and go into now the thrust reverser cowls. Thrust reverser cowls, and just so you know, with the thrust reverser, obviously it has to do with reverse thrust, which just has to do with the redirection of airflow to help with the aircraft to slow down at touchdown, right? Your assembly encloses the engine core, and it's just going to give, by doing that, it's going to create that exhaust duct. And that's where the air is flowing. And then of course we have doors there. They're going to block the airflow so it can be in kind of a different direction, so they're, you know, the opposite direction, so it can slow the plane down. But the thrust reverser is made of 2 similar halves, like I said before. Those are your C ducts. There's each half has some components. Okay, so just keep an aware. Just be aware of this. You know, again, you don't have to memorize all of this. There's going to be a latch beam. I'm going to mention the latch beam a little bit later, but there's a latch beam. You're going to have your latches closed, and that's going to be locking the halves together, okay, and giving access to the engine core component when you're doing maintenance. There's a torque box as well. There's an interfixed structure There's also, I mentioned the translating sleeve. Okay, those are the ones with the blocker doors. Blocker doors because it's blocking the airflow. Okay, so, and that's when that happens, then it's creating the energy because it's blocking that air and diverting it. There's the actuator's access panels that are located on the outer surface of the translating sleeve, and that's going to allow access to the actuator's attachments to the translating sleeve. Okay, so just be aware of that. Of course, there's hold on open rods as well with the thrust reverser cowls. All right, now let's just talk. We're going to talk first on the left thrust reverser cowl latches, and then I'm going to move to the right thrust reverser cowl latches. And be aware they're not all the same. There are some of them. They're just different. They're different types of latches. All right, and they're numbered. So, just be aware of that they are. Follow the sequence in your maintenance manual. It's just very key. Also, there's a lot to rigging because you want to make sure everything's aligned properly. So, there's again the protective devices in there to make sure everything's good. But the left has different aspects to it. You have, first of all, the labeling of the latches of L1, L2, L3, etc. There's L1 is a dual hook latch. So remember I said there's different types of latches. With latch 1, this is a dual hook latch that's controlled by a handle. L2, you have what's called a take-up latch. So it's like a long stroke type of latch. And then you have conventional hook latches for 3 and 4 and 5 as well. And then 6 and 8 are compression arms that come in contact with the remote latches on the right thrust reverser cowl. Okay, so there's a connection between the left and the right reverser cowl latches, just so you understand. 3 and like I said, 3 and 4 are conventional hook latches, and then L5 is a conventional hook latch. It's also unlatching the remote latch L7 with a cable. So there's your L7, which, by the way, L7 telescoping rod is connected to the 2 thrust reverser cowls. So seems confusing, but just know that there's different kinds of latches. They're not all the same, and they're labeled L1 through L8. And they, again, like I said, there's protective devices to make sure that they're closed properly. All right. Now the right thrust reverser cowl latches and access panels. With the right thrust reverser cowl, you have L6 and L8 remote latches that have compression arms, and those are connected to the left thrust reverser cowls, okay, that come in contact with the remote latches. And you have 2 latch access panels here with the right thrust reverser cowl latch beam. And when it's in the open position, then the latch access panel is going to give you access to latches 2 through 4 and the L6, L8 release handle. Okay. All right. Test question. Potential test question. Okay. All right. Question number 6 on your in your handout. The right thrust reverser latch beam has 3 latch access panels. Is that true or false? Okay, the answer is false. I said there's two latch access panels. All right. I know I mentioned this one. The PDOS stands for the power door opening system. Is that true or false? That is true. All right. Let's go ahead and go back to our lesson here on the thrust reverser cowls latches. All right, like I mentioned before, you get 2 access panels with the right thrust reverser cowl latch beam. Okay, that's where we last left off there. And that's what you have. Now the opening and closing of the thrust reverser cowls, there's, like I said, a sequence. Don't have to memorize all of it. But just remember you've got pins that you need to remove before moving a handle not for all of them, just for some. And then you've got to pull, you've got to install a handle pin, and then put the extension into the end of the handle, and then release the over center lock trigger. So there's a trigger that you'd have to release. So I mean, there's different methods depending on which latches you're opening. So gives you an idea. And there's different degrees of open position or over travel position, etc. Obviously the stowed position is completely closed. All right, but that's what you have with that. Again, just follow sequence at your MRO from the actual aircraft maintenance manual. Your hold open rods, I mentioned before, with the hold open rods, that's just obviously making sure that the fan cowls are secure when they're open, when you're doing maintenance in there. Okay. The hold open rods, there's that, remember I mentioned that locking collar. It has, on that locking collar, it's going to let you know whether it's locked or unlocked. If it's locked, it's green. If it's unlocked, it's going to show red. So just to be aware of that. And on the door, power door opening system, this is just obviously helping with the opening and closing of the cowls. And as far as what components you have with the PDOS, okay, you have a power pack. You also have the actuators. You have 2 fan opening actuators, as well as a set of the 2 thrust reverser opening actuators. You also have switches and a fan cowl proximity switch. Okay, so those are your actual components. As far as your electronics goes with all of this, obviously we're talking electrical. We got these components here. You have a conversion module that's here. So when a control switch is pushed and it's held, then you're going to have that logic module in the power pack send a signal to a conversion module. Okay, that's also using the fire protection system. But that CM, which is your conversion module, is going to send that information to the engine interface function, which is going to go to another computer. I know it's computer to computer to computer, right? But that's just how it goes. And it's going to go to the power distribution system so they can supply electrical power to, the power pack and the solenoid valves. Because I said it's whole electrical. There's also protection against the collision between the fan cowl and the inner slat that the PDOS has in place. So when the inner fan cowl is open more than a certain angle, then that proximity switch is going to send a signal to that module, and it's going to stop it. So we don't have damage from one component to another. All right. Now let's just say that for some reason you have a failure of the opening system, power door opening system, then you could actually push, manually push the fan cowls to an open position. That is possible, just so you know, in case you didn't know that. But so that's your last resort. There's a quick disconnect that's fitted to each of the opening actuator. It lets connection of an external pump be available there, okay, to help out. And then you have your power pack that's also installed at the top of the fan case. So you have that. There's a refill port that's at the top of the power pack reservoir, because you have a power pack made of a reservoir. You have the electrical pump as well, like I said, the solenoid valves. So it's all part of that. Okay, so, but that's normally it would be a power door opening system that brings those cowls up and down. All right, so that kind of gives you an idea. There's a lot of latches, different types of latches, and different opening position or angled, different opening positions for the cowls. And of course, there's a sequence in which you need to take carefully, otherwise you will cause damage to the fan cowls. All right, if you have any questions, just do reach out to us and email us. I just want to make sure you get the answers there for the questions that we covered. All right, Okay, we look forward to seeing you or having you in our next session, which is session 3, the thrust reverser system. This is session 3, thrust reverser system for the Airbus A350. And we are continuing on. Thrust reverser system. What can we say about this? We're going to go over the components, also the lines of command. That means what signals are being transmitted to what components. A lot of avionics that we have with the thrust reverser system, just like the other systems. The thrust reverser system is obviously part of the engine, which is the RollsRoyce Trent XWB, that is all electrically controlled and operated. We'll get into some parts that are going to be a mixture of electrical and mechanical, but when we talk about the reversers, they are electrically controlled and operated. There's a left and right side, so you have thrust reverser cowls for each engine, and a translating sleeve. Translating just means something that slides. That's going to be able to be in a stowed or deployed position given commands from the cockpit. The lines of command, there's different kinds. When the pilot is deciding to execute the thrust reverser position from stowed to deployed, there's going to be signals generated going to the primary and secondary computers. The signals are coming from the potentiometers as well as the signals from a radio altimeter system. So those are the two places where signals are coming from and going to the primary computers. And the computers are going to be telling the electrical power distribution center system to release the track locks, because these the thrust reverser cowls are in a locked position until they get deployed. So those locks have to be obviously released so that the cowls can be released, deployed. Now, if there's some reason that the primary computer is not operating, then you have two set computers that are going to take over. Remember, we always, for the most part, have redundant systems, and we certainly have them here. The line of command, we're talking about the third line of command is going to be controlling that independent locking system. And you also have the first line of command, which is supplying the electrical power to the actuation, controlling system, so controllers. And that's just being able to unlock the locks on those cowls. There's the second line of command, which is giving a stow or a deploy command to the E-track. Okay, that's the system for the actuator system. And that's going to use that electrical power to control the motor. The motor is connected to 3 actuators, by the way. You have 3 actuators per thrust reverser. That's going to be for each side, so that's per engine. And in order to unlock those tracks. There's also a fuse box that's installed that's below the E-track, and that's just going to give protection for that system in case there's an electrical problem. There's transmitters that are going to send the position of the thrust reverser lever. It's going to be going to a couple of interfaces. Number 1 is going to be your EEC, okay, your electronic engine control, and also your EIF, which is your engine interface function. Those are the 2 computers that it's going to be sending it to. And why do you have these intermediate components? Because we're having to translate or convert the types of signals. Okay, this is a whole subsection or branch of engineering called signals processing that talks about the different kinds of signals. Here in particular, we're talking about analog to digital. There's also our other types, but right now I'm talking about analog to digital. So you have a digital signal that will be produced after going through these interfaces, your EIF and your EEC. Okay, so you've got those 2. So from EEC, actually, then it goes to the EIF applications so that it can give the commands correctly for everything else pertaining to the deployment of those thrust reverser cowls. Now, if you have, for example, the aircraft's on the ground and depending on what position the thrust reverser is in, you're going to have an EIF application that's going to send those commands to the E-track. It's going to be doing it through the computer network. There's a network AFDX, which is just an Ethernet. It's just a cable system, but I'm talking about computer wiring to send the signals. If for some reason the application's not working, then you're going to have another application that's going to take over to ensure that that occurs. So a lot of chain reaction with the thrust reverser lever position that is put and executed by the pilot. Now, what about components? Okay, I mentioned about the cowls, but you also have, remember I said you've got actuators. There are 3 actuators that are connected to an electric motor, and that's per engine. And there's the locks. Okay, how many locks are there on the translating sleeves? There are 2 primary and 1 track lock. So 2 primary locks and 1 track lock. Those are powered and controlled by what I mentioned before, which was the E-track. Okay, that's your actuation controller. And obviously this is all electrical, so but that's what that computer does. And it's doing all of this through the auxiliary fuse box. Okay, 1 per engine. All right, so the computers involved are the primes, or your primer sec computers, and then your electrical power distribution center is involved because this is electrically controlled and operated, so you have that coming into play. All right, I think it's time for a few test questions, potentially. Okay, let's start here. What is the function? Let's do number 8. What is the function of the thrust reverse system? All right, that's going to be to slow slow the plane down. Okay, that's the whole idea. Is it's actually redirecting airflow to create an air brake for that aircraft. So the answer is the first one: slow the plane down at touchdown by redirecting that airflow. All right, question number 9. What are the components of the translating sleeve? I didn't talk about links, but we do have links, and of course blocker doors. There's other terms you might hear in the industry, but here for the purposes of this instruction, it's blocker doors. But you have 1 sleeve and you have 6 blocker doors. 6 blocker doors. For each of those you have 6 drag links. Okay. All right, so let's go ahead and go back to our lesson. So it gives you a little bit of an idea of the kind of the electrical paths that are happening when the pilot puts the that lever in position, whether to stow or deploy. All right, so and just acronyms and abbreviations, and I mean there's a host of those in every industry, but in the aviation industry is no different. You will find the meanings of these abbreviations at the beginning or top of your handouts, okay, your video notes and review. All right, let's talk a little more about the components involved in the movement of the cowls. You have an electrical motor, like I mentioned before. You also have your actuators. There are 3 of them, and they're taking the rotational. The whole idea of this whole system is to take that rotational movement of the actuators, of the electrical motor, and into more of a linear movement. So rotational to a linear. You have upper and lower actuators, and you also have a center one. There's also a hook, a solenoid that's moving a locking pin that's part of the track lock. You also have flexible shafts, you have a proximity switch, and you also have a manual unlock lever. All right, what about the stow position? All right, so let's just say that the crew, pilot decides to not select the thrust reverser. Then what's going to happen? You got that electrical thrust reverser actuation controller, right, that's receiving that signal from the EIF, okay, your engine interface function. Of course, then you have your E-track that's distributing the electrical power to the motors so that it can be putting those cowls in the stow position. So motors are driving the actuators are driving the cowls to be in a stowed position. Now what about deployment? In the cockpit, the pilot puts it in and selects thrust reverser. Then you're going to have the electrical power distribution center that's going to be, or system, excuse me, that's going to be energizing the track lock solenoids, okay, to release them, to unlock them. There's the hooks, they're going to be open with the spring action, and then also it's supplying the power, obviously, to the locks to do all that. So that's what the E-track is doing. It's distributing that electrical power to the locks to undo when the command is for having the thrust reverser system in place. All right, and what about monitoring all of this? You have your electronic engine control that is monitoring, okay, through transmitters that are located on the actual actuators, and being able to just monitor that and making sure things are properly in position where they need to be. It's also checking for overspeed, and anything having to do with any system, you got to watch temperature, pressure, and quantity. Okay, so pressure, temperature, and quantity. Here, the monitoring is also monitoring the speed and the overheat in case there's something gets too hot. So it's monitoring that as well. Now, I mentioned the manual unlock devices. Those are there on the actuators, and you also have an unlock lever on the track lock, and it's just allowing you to manually unlock each of the sleeves separately. Okay, and just make sure you use the proper tools. I know there's a lot of makeshifts out in the field, no matter what industry. I work in some hydraulics, in the hydraulics industry, and sometimes that happens. It's not recommended. Maybe it'll be okay, but I'm not the one telling you that. That will be something that you need to discuss with your supervisors and get approval, etc., for tools that you're going to use for a particular task. So when it comes to maintenance, be mindful of that. Also, when you're going to do any kind of manual locking or whatever, it is possible with there's a lock lever installed on the center actuator. Okay, so you can actually lock it with that lock on the central actuator. Now, where's the electrical motor located? Okay, the electrical motor that's connected to the 3 actuators on each engine, it's actually located in the center. Okay, there's the center actuator and electrical motor. Those are both in the center. So those are including the lock lever, okay, and a multi-display unit. Or you have also an electrical harness. If you have electrical power that's going to be distributed, you're going to have electrical harnesses that's going to be supplying the power and controlling what's, basically the signals traffic, right, that's going on. You also have flexible shafts. You've got the electromechanical system that's pretty much the same whether we're talking about the system on the left or the right cowls. Okay, and what when you look at the structure itself of the cowl, what components are here? Okay, we have the blocker doors, and there are 6 of them. Okay, we covered that in a test question, but there are 6 blocker doors that are hinged to that sliding sleeve at the front end. There's also drag links that are hinged to the blocker doors at one end, and then there's some hinged to the inner fixed structure of the cowl on the other side. All right. Okay, and they're flush. When they're stowed away, it's just you shouldn't have any any raised part of it. It should be flush, just for the record. Okay, so all right, let me make sure it covered things. All right, so we covered that those parts. So you've got those answers on your handout. Okay, we just went over that. All right, let's continue on and talk about cascade boxes. It's basically here you have a protective cover. This is a cascade box that's installed between the aft cascade ring and the torque box. And what it's doing, you know, what's the purpose of the cascade box? What is its function? Well, it's going to be diverting fan airflow in different directions when you have a deployment of that translating sleeve. Okay. Now, things may look alike. I know I've given a great situational awareness here when you're on the job, that a part may look exactly like another part. But if it doesn't have the exact same part numbers, you know, for each one, then, you know, you've got a different part, and you cannot just substitute one for another. So in this case, with the cascade boxes, they are not interchangeable. So please be careful before you install something, make sure the part number is the correct one. The protective cover must be open, okay, obviously to access the unlock lever. There's an unlock lever. And there's, remember I said the track lock, there's one track lock. That's installed on the latch beam. And that has the unlock lever that's a manual type, and then you have a hook as well. Okay. There's also a visual indication pin that you can use. It actually gets pushed, and that just lets you know that the latch access panel is closed. So you have some indications there when you're needing to access things. Okay. All right, so let's go to a potential test question. This is number 10 on your video notes and review. What is the function of the cascade boxes? Is it 1, to guide the air-fuel mixture into the turbine section of the engine, or is it to guide the airflow into the forward or side direction when the sliding or from the translating sleeve is deployed? That's going to be the last answer. Okay, let's do a couple more. I did cover about lines of command, so I'm just kind of going back to that right now on our handout here. But the third line of command gives stow or deploy command. Is that true or false? Okay, that's false. It gives control of the locking system. All right, 12. What is the role of the radio altimeter as it relates to the thrust reverse system? Is it A, it sends signals to the engine interface function, or it sends signals to the primary computers? Okay, it's sending them to the primary computers. I know signals are going to both, but in this particular case, specifically, the signals are going to the primary computers. Okay, now, number 13, the translating sleeve is a hydromechanical system. Is that true or false? That's false. It's electromechanical, not hydromechanical. Number 14, some components of the electromechanical system for the translating sleeves are, okay, A, proximity switch, flexible shafts, 3 actuators, track lock, and an electric motor? Or is it B, proximity switch, non-flexible shafts, 2 actuators, 2 track locks, and an electric motor? The answer is A, because there's 3 actuators for one. Option B says there's 2. Well, in pure logic, there's 2, yeah, but there's not just 2. But there's 3 actuators. Plus, there's only 1 track lock per side. All right, number 15. Where are the cascade boxes located? Option A, is it between the hinge beam and hold open rod, or between the torque box and the aft cascade ring? B, right? Option B. That's where I just mentioned a bit ago. All right, let's go back to our lesson. Okay, so let's see what we were talking about, the cascade boxes, right? And we're going to be looking here at let me just look here a little bit. We're talking about the cascade boxes and the track lock, and now the deactivation. How do you deactivate the thrust reverser system? Because you're needing to do some work on it, and that's what you need to do first. Well, we need to make sure electrical is not running, for one thing, so you want to be careful of that. So you're trying to, you want to make sure that there's a deactivation of electrical. Okay, and you're going to do that through the OMS, which is your onboard maintenance system. Be familiar with that. There's a lot of avionics involved, and if you're not familiar with these, do ask. Do make sure that you do step-by-step procedure when you're entering information or selecting choices on the OMS. This part of it is the power distribution monitoring and maintenance function. Okay, it's going to it commands the distribution center so that it stops the electrical power that's going to the actuator or actuation controller. All right, so remember, just keep in mind that you want to follow exact procedures at your MRO, but that's the general idea with that. And that's if you're doing maintenance on the engine and you need to shut down the thrust reverser system, because you may need to have the thrust reverser system active to test it, right? So again, follow procedures so that you stay safe. All right. There's also deactivating the thrust reverser for dispatch, and with the electrical deactivation, you're still going to use the OMS, your onboard monitoring or maintenance system, excuse me, and that same one or aspect of it, your power distribution part, because again, you're trying to shut down its source of power, which is electrical. So you're going to still be doing it that way. On the electrical deactivation. Now, mechanically deactivating it, you're going to have to go into the latch access panel. Okay, and actually secure that so that it basically you're blocking it, so there's no way it can mechanically be activated. All right. So just again, be careful about opening and closing, just for your safety. Make sure you stay clear of its potential path if it ever got activated inadvertently. But hopefully that won't be the case. Okay. All right. Let's go here to our last question, I believe, and that'll be number 16. And that's before doing maintenance on the thrust reverse system. It's really on the engine. If you thrust reverse system, you may have a slightly different procedure depending on what you're doing with it. But for the purpose of this question, before doing maintenance on the thrust reverse system, how do you deactivate it? Is it option A, through the circuit breaker located behind the captain's seat, or is it through the onboard maintenance system? Okay, option B, right, through the OMS or onboard maintenance system. All right, so that gives you at least a general familiarization with the operation of the thrust reverser system and the computers that are involved, your interfaces, your lines of command. And just to cover, so we're not, I want to make sure it's a little bit clearer for you on the lines of command and this whole electrical signals paths that are going on. Back to that, if we talk about first line of command, it's supplying a source of electrical power to that E-track. Okay, your E-track, remember, it's your electrical thrust reverser actuation controller, because it's taking that electrical power and sending it through another module or control. It's a controller, okay, and that controller is taking that electrical power and sending it to operate the motor and to unlock the primary locks. That's what it's doing. Okay, then you have the second line of command that's giving stow or deploy command to the E-track. Okay, that's to unlock if it needs to be unlocked for deployment. Okay, and then third line of command is controlling the independent locking system. And what I was saying before about primary computers is going to be receiving signals from the thrust lever position through the potentiometers and also from the radio altimeter system. And those discrete signals are going to be sent to the EPDS, your electrical power distribution center or system, and it's going to be releasing the locks. All right. Be careful. Make sure you understand the safety as it pertains to electrical power, because it can obviously cause fatality. So I just give that as a heads up when you're if you're going to be assigned to working on this system, or really any of the other ones as well. But right now we're on thrust reverser, so just to mention that to you, just be mindful of all that. All right, if you have any questions about specific components or the process, definitely email us and let us know. We will do our best to get answers for you. All right, well, thank you for participating in session 3. We will be moving on to our next session on propulsion control system.